Hello again, everybody. Colin Archibald here. I'm working from my house today in Ocoee. So the way that we started off this class is we had you set up an Android development environment and actually make a couple of small Android applications that really do something. But this isn't an Android development class. Most of it will be Android. But now that we've gotten this far, I want us to step back a little bit for a while and look at mobile device software development, the big picture, not the historical context, we already did that, but the big picture. Why are we doing this? Why is it interesting? What are these mobile devices? Well, programming for a computer that's different from the computer that you're writing the code on, we've always been doing that for not for the consumer market, but mostly for the industrial market. You program for industrial automation. There's all sorts of little devices that need to be collecting data and actuating robots and things like that. So we've often called this cross-compiling. You write some code and you compile it, and then you put it out on a different device where there's a processor that executes the code. So we're not going to be writing code on a telephone, on a smartphone. We're going to be writing code on our desktops and laptops, and cross-compiling and deploying onto the target device. So target devices, they're not really new. Everybody thinks that they're new. Remember the Apple Newton? Remember the Palm Pilot? Apple Newton goes back before Palm Pilot. People think that Apple discovered the smartphone and it didn't take very long. They have decades of work in handheld computing devices. Decades. It's not something that just happened in the last 5 years, although the money and the mass production showed up in the last few years. So what are these devices? Small ones like this, smartphones. They have telephone technology in them, and this is representing the merger of a cell phone with a handheld computer. The smaller ones have mostly gone away. Less than 3-inch screens have mostly gone away. Up to a 5-point-something inch screen, I think 5.1 inches, is called a phone. If it's between 5.1 inches and 7 inches, it's called a phablet. If it's bigger than 7 inches or bigger, it's going to be a tablet. Here's my old Samsung tablet. This one is the first Kindle Fire. It's also an Android device running Android 2.3.3, the first Kindle Fire. Bigger tablets. I'm glad you can't see my desk. What a mess. Bigger tablets. Here's an Asus 10-inch tablet. All of them have touch screens. The input device that we use now is a finger. So phones, phablets, tablets, and then something in between a laptop and a tablet. So Microsoft has been exploring this. Can't reach everything on my desk. Microsoft has been exploring this. This is a Microsoft Surface, and it has this nice thing where you can stand it up on your desk, and it has a stylus with it for inputting other than with your finger, and it also has a keyboard, so you can sit it into a little slot that allows you to type on it. And this runs Windows 8. There are newer ones than this one that I have. This is the keyboard, believe it or not. I wonder if you're going to be able to see that. It's like a piece of cardboard, and typing on it is barely usable. And I hope you can't see how much dust there is on this, but that would give you an idea of how much I'm using my Windows Surface tablet, and they are calling that a tablet. And all of this has happened not so long ago. This one is still one of my favorites. This is the first Android device that I had, and it was made by Samsung. The interesting thing about it, it's quite old now, but it had an AT&T account on it. So this has this tablet, 7-inch tablet, kind of the Kindle form, like the size of a paperback book. It has telephone technology in it. And when I was thinking about what one I would buy, the very first one, I thought, well, I'd like to experiment with telephone technology, but I don't want a little tiny one. I can't put this in my pocket. It doesn't suit as my telephone because I can't put it in my pocket. So it's awkward. People got tired of trying to use the little tiny phones. If your whole life is on a phone that is this big, it's really awkward. So what seems to be the format that's becoming popular right now in 2014 is the phablet. So a 5 or 6 inch phone. It kind of fits in your pocket. It's big enough to be able to see things on. You can conceivably read email and respond to email on it. We'll see. Consumer-facing electronics are changing. So there's going to be more of these devices that people carry around than there are desktops. Well, we know that for sure. There's even going to be more of those than there are laptops, and that transition has already happened. So consumer-facing electronics are going to be devices that we as programmers probably won't be doing our work on. We're going to be cross-compiling. We're going to be writing software for devices that people carry around, either held in one hand or held in two hands. The input device is not going to be a mouse anymore. It's going to be a finger and sometimes a stylus. The stylus hasn't proven all that popular. So we're going to put software on these as the software developers, and you kind of know already the most common ones. The Android device has the bigger part of the market share, but not as much money as the iPhone. So the iPhones are more expensive, they're more robust, there's not that many kinds of them. In fact, all iPhones are produced by Apple. And then there's the Android devices. There's more of them physically in the world. They are manufactured by any number of companies. And Android devices are an open standard. An open standard. That means that if you want to start a company and build a device and put Android software on it, you can. It's open. What other ones are out there? The BlackBerry. The BlackBerry was the most popular handheld device, telephone and personal computer, up until the iPhone. So that was a Canadian company that has really very rapidly crashed and burned. What is the fourth one? Windows Phone. Windows Phone. And this has a very small part of the market up until now. Don't count out Microsoft. They have enough money and enough human resources so that when they decide they're going to do something big, they will make it happen. They will market it until it happens. So Windows Phone, Windows 8, these operating systems and these user experiences are starting to look the same. So this is the objective, to make all of the consumer-facing electronics that you own kind of look and feel the same. So your laptop, your tablet, and your phone, you should know how to use them because they work something like the other one. So Microsoft has taken this big leap with Windows 8, and they've kind of made the laptop look like the phone. And for me, on my laptop, that didn't work very well. I think for the phone users, that hasn't worked very well either. They also bought a manufacturer of phones. They bought Nokia. Very, very good hardware. Very recently, HTC has started manufacturing a phone that will run Windows Phone 8. And it looks like this. This is the HTC One. It's a very nice device. One of the last American companies that are manufacturing these devices. So there's the big four. There's a couple of other small players. Okay, no, there's one more player that has to be mentioned here. The fifth one, which is also coming very fast, is Amazon. So Amazon, they started out with the Kindle, the book reader, then the Kindle Fire, which it was their first Android device. That's the first Kindle Fire. The Kindle Fire HD. Very recently, Fire TV, and even more recently than that, the Fire telephone. So Amazon is going for this end of the market, the tablet to telephone. They haven't made and television. They haven't made a big grab for laptops, and certainly nothing to do with desktops. But Amazon is a major player. So there they are. Android and Android flavors, including Amazon. Apple with the iOS operating system. Windows Phone, Windows Phone 8, big disaster. BlackBerry, which has pretty much gone away. So we've got these devices that are small. They have to be necessarily small. You're going to carry them around. In fact, I'm laughing at how heavy this one is, and it's only a couple of years. This was my main phone. Very dusty right now. This was my main phone, another HTC phone. Is ridiculously heavy right now. What was I going to talk about there? Resource-constrained devices. They have to be small. We're going to carry them around. They're not going to be plugged in all the time because they're in your pocket, so they have to have a battery. And they have to have a battery that will last the whole day for as much as you're using them. They have to be cheap because there's going to be, they want everyone to have one. So because they have to be cheap, the screens are going to be probably smaller than you might want, with fewer pixels than you might want. The battery is not going to last as long as you might want. They're not going to have as much memory in them as you might want. And the processor's not going to be as powerful as you would want. So an Intel chip, like running in the desktop that's recording this video, wouldn't last. In a phone, it couldn't exist in a telephone because, first of all, it would get so hot it would burn you. And then the battery would go dead because it takes so much energy, there's no way that you could carry that around. So all of these devices are resource constrained. We can't just say we're going to write software and it doesn't matter anything about it. We don't worry about how much memory we have or how much battery power we use up, how much network communication we use. So it's a different kind of software development. We're very, very constrained by the resources that exist in the hardware devices. So we can have software running on these devices in different ways. The one that's most commonly known to programmers is the way that you've started doing it now in Android. You write code in Java and you build an app, an APK file, an Android package, and you deploy that to the device. This is called a native app or native Android programming. That's a little bit confusing because there's another layer underneath that in Android called the Native Developers Kit, the NDK, as opposed to the SDK, the Software Developers Kit. And the native developers kit, you work in C and C++. It's actually C99. But what we usually refer to as a native app is software that's developed specifically to run natively on a particular device. So a native Android app is coded in Java and runs on the Dalvik virtual machine, or something very similar to that in the case of Amazon. In iOS, the language for native code development is Objective-C. Very, very awkward language. Very robust. It works. When you get it working, it works the same way all the time. They have blinked. Apple has released now a new language called Swift, and we're in this transition period where development for iOS is moving from Objective-C to Swift, and the early reports are that the Swift language is really, really nice. And if enough people will switch to that, then the development on iOS will get easier. Windows 8 development is done in C#. So if you have Visual Studio, you can build an application for Windows Phone. BlackBerry, I'm not going there. It's gone. It's too bad. But let's face it. So C#, Java, and Objective-C or Swift. Native development. Native app development. If you have an app and you want everyone to be using it, you can't deploy it just on one device, one operating system. You have to deploy it at least for Android and iOS, the two that are most popular right now. That's a problem. You need two sets of skills. You need two development teams, or you need one very unusual development team that can work in both environments, working on Macintosh and PCs. Well, actually, Android development works very well on Macintosh, so that kind of a shop might be a Macintosh shop if you're going to do native development on multiple hardware. There's an alternative. All of these devices are connected to the web. You know that. You can go and browse the web. You have new websites that are specifically designed for mobile devices. Usually the URL starts with m. And a lot of people are accessing websites through their mobile devices, and there's some numbers that maybe even more internet activity is now happening on mobile devices than on laptops and desktops. Okay, so why don't you just make a web page and serve it to the mobile devices? And there's an app. So an interactive web page. The advantage of that, the big advantage, is all of these devices, no matter the operating system, have web browsers on them. So if your app can be designed as really just using web technologies, so you have an interactive web page, but it's running on a mobile device, that's kind of like an app. The big advantage is you only need one of those, and it runs on all of the devices because all of them have a web browser technology in them. So we've got native on one end, we've got the mobile interactive website on the other end. Maybe you can get away with just doing a website and you only have to develop once. And there's a lot of people around who can do web development. HTML5 is a powerful technology. Then there's something in the middle. And in fact, there's a lot of things in the middle. There might be a native app, so for Android, and a Java app, but one of the objects that you can make an instance of is a web view. So you might say, I'm going to have a native app coded in Java, but the front end, the visual part, the user experience part, is going to be a web view. So the front end looks is coded kind of like a web page. Well, it is coded like a web page using web technologies, but the back end is native development in Java executing on the Dalvik machine. So a hybrid where the user experience is using web technologies, but the back end is using native code for that device. How are you going to decide what would be the right thing to do? I want you to watch a video. Rito Meyer is one of the chief engineers from Google. He usually makes sense to me. Not all of them do at Google, but Rito Meyer makes sense to me. And here I'm going to give you a link to a video which is a debate between whether you should be doing native code development or you should be doing web technologies code development for putting things on these mobile devices. It's maybe the most important question that we have right now. If you don't need to build 3 different versions of your app, then don't. We tend to choose the technologies that we like, and we like the ones that we know. So we're choosing Android development, native Android development, because it's Java, and everyone in this class knows Java, but it might not be the right choice. Okay, so I'm going to let the real experts in this debate the merits and what the technologies are that would be on this scale from native development to web-based development for mobile apps. And then we're going to have you explore some different technologies, download and make Hello World using different technologies. It depends on what hardware you have personally, which options you will choose for your assignments, but so long as you have some experience with other ones and you're thinking about, for your app, what are the right technologies to most efficiently bring your product to market. And it might not be the one you like, the one that you're having fun with, working with right now. Okay, we're at a fun place where we're stepping back from our face into one technology, and we're going to look at the breadth of the software technologies for building apps, and then we're going to go back in eventually and work in Android again. Good. I'll see you later.